Consider a 5-stage instruction pipeline which can execute 3 types of instructions. Each load and store type instruction takes 8 cycles to execute in pipeline. Each ALU instruction takes 6 cycles to execute in pipeline, and any other type of instruction takes 5 cycles to execute in the pipeline. There are 20 load and store type, 30 ALU and 10 other type instructions to execute in the pipeline. How many cycles are needed to execute all instructions if all the instructions can be overlapped? So there are 3 different kinds of instructions which are possible in this system: the load and store type, the ALU type, and a few other type. And the number of cycles required for each type are given to us. So the total number of instructions which are given is 20 load and store type, 30 ALU and 10 others. So total number of instructions are 60. So let's say that there were no extra cycles that were required. So each instruction would require 5 stages to execute. So in that case, the first instruction would require 5 clock cycles, and the remaining 59 of these 60 would be completed in 1 cycle each, so they would require 59 clock cycles. So the total number of clock cycles that would be required would be 59 plus 5, which is 64. Now some of these instructions are taking some extra clock cycles, like load and store is taking 8, though normally it should have taken 5 because it is a 5-stage pipeline. ALU is taking 6, whereas they should have taken 5, so it is requiring 1 clock cycle extra. And the other type are requiring 5 cycles only, so they are not requiring extra cycles. So the extra cycles are being required by load and store and ALU only. So load and store is requiring a total of 8, whereas it should have finished in 5. So the extra cycles that are required are 3. And there are 20 of such type of instructions. So 3 into 20 gives us 60. Also ALU, it requires 6 clock cycles, though each instruction should have required 5. So there is 1 extra clock cycle that is being required, and there are 30 such instructions, 30 ALU instructions. So 1 into 30, which is 60. So to the total which we had computed earlier, had there been no extra cycles, so 64 plus the extra cycles that are required, 60 plus 30, this gives us 154 clock cycles.